Today we are going to discuss how to delete a node in singly linked list. Look at the diagram. We have already seen in insertion itself about the head pointer. So if you don't know means look at the description box. I have added a playlist link there so you can see all videos over there. So coming back to the concept, head is a pointer pointing first node in the list. So I have two pointers here, that is previous and temporary pointer. So what I need to do in order to do deletion is I have to alter the links, that is I have to cut the links, so a node will be separated from the list. So free the memory of the node, that is delete the space occupied by the node in the memory, so that node will be getting deleted. So I have to do 3 steps. First step is, look at the diagram. You have to delete the node C, means find the previous node of C. So who is the previous node here? That is, who is before C? B is the node before C. So you have to find that. This is step number 1. Then step number 2 is I have to change B node's next field. That is, I have to delete node C. Right. So B's next field should point C's next field. That is, it should point node D. This is the second step. Third step, now the node C does not have any link with its adjacent nodes. So who are the adjacent nodes of C? That is B and D. So B and D are neighborhood nodes of node C. C does not have any connection with node B and node D. That is not connected with the singly linked list. Now the memory occupied by the node C is totally waste. So free that memory space. This is the third step. This is the important third step. Free means clean it, that is delete it from the memory. If you understood the concept, we can move to the code now. These are the 3 points I have explained over here. Then code, void delete, head pointer and key I am passing as parameter. Key means which node I need to delete, that is called as key. Okay, so I am assigning temporary pointer variable, and if head node itself holds the key to be deleted, then follow the this code part. I am checking if temporary is not equal to null and temporary data equal to key. Key is what we have mentioned is found. Then I am assigning temporary next as head pointer. Free the temporary pointer. So this part clearly says that I need to delete a node if that node itself is a head node. Means, so these are the steps I need to do. Okay, then come to the while part. While temporary is not equal to null and temp data is not equal to key, then change the pointer. That is, change temporary as previous and temporary as temporary next. Okay, imagine if there are many nodes are connected in singly linked list and key what you have given is not found in the list, means you have to traverse through the entire list in order to find the key to be deleted. Okay, for that you have to move the pointers. So that only I am changing the pointers in while condition. So if the while condition fails means, that is, if the node to be deleted is found means, so here is the important step. Here is the concept comes. That is, you are joining B and D, leaving the C node without any connection with B and D. So look at the diagram. Temporary next equal to previous next. So here is a very important step. Focus here. Temporary next is equal to previous next. So that is C's next is D. Who is temporary next? C. Okay, so C's next is D. I am assigning that to B's next. Okay, so now B's next is pointing to D. Main task is getting completed here only. Okay, so I am repeating, temporary next is equal to previous next, that is C's next is D. I am assigning that to B's next. Now B's next is pointing to D. Okay, so this is the main task. Okay, just go to the previous line. if temporary is equal to null, return. So what this line of code says is, if key itself was not present in the entire singly linked list, then no task can happen here, no job can take place here. So you need to check this condition also. So important line is previous next is equal to temporary next. Now node C is left out from the list. Okay, there is no connection between the adjacent nodes, but it is occupying space in memory which is of no use. That is purely a memory wastage. So delete that as well by using free function, that is free of temp. Okay, so you have successfully deleted a node in singly linked list. So hope you all have understood this. So if you have understood insertion and deletion basic concept in singly linked list, means you can write routines on your own. Whatever question is asked, you can solve it simply. Also, if you understood singly linked list, means you can easily understand the coming portions, that is doubly linked list and circularly linked list. So they are all very easy, but you need to understand singly linked list. Before understanding singly linked list, you cannot go to doubly linked list and circularly linked list. So understand the singly linked list, practice and again then again, and you will find it very easy. Okay, so data structures is the core paper main part of CSE. So practice, that's all I can say. Okay, thank you, take care.